Welcome, explorers of the universe. My name is Elian, and today I am opening the doors to the world of edges of reality for you. This is the place where science meets fiction, and where the question is what if he'll find his answers. Many of you have heard about parallel worlds in science fiction films and books, but what if I told you that they can exist in our reality? Would you believe me if I said that our entire reality is determined by tiny particles, and no one knows who controls them or where they get the intelligence to do exactly what they do? Otherwise, second-hand physics is the latest innovation in the field of reality research. Using pulses of light that last a millionth of a second, researchers uncovered the secrets of the subatomic world. And it was for this that 3 researchers were awarded the 2023 Nobel Prize in Physics. The Swedish Academy of Sciences in Stockholm has decided that working with such extremely small units of time as attoseconds is of great importance for physics, and for our understanding of the world, and that it deserves the Nobel Prize. Now you're probably wondering what attosecond physics really is, and quite rightly, because until now this area of physics has been little known. An attosecond is a billionth of a fraction. Seconds. It is such a tiny unit of time that we will never be able to grasp it with our minds. But we can make a comparison that will make it a little easier to understand this unit. In 1 second, as many attoseconds pass as attoseconds have passed since the birth of the universe. Exciting, isn't it? The realm of these attoseconds is also the realm of electrons. Electrons are fundamental subatomic particles that revolve around an atomic nucleus. With a negative electric charge, electrons act when atoms combine to form molecules. Therefore, the behavior of electrons determines the properties of matter, which is based on atoms. Electrons and their behavior continue to determine not only many processes in nature, but also very practical things, such as the electrical conductivity of things, magnetism, or the chemical reactivity of elements and their compounds. Nobel Prize laureates in attosecond. The physicists are Pierre Agostini, Franz Krauss, and Henry Lullier. All 3 independently developed special methods to generate light pulses in the attosecond range. This allows you to practically tickle or stimulate the electrons, so that they exhibit a certain behavior. Although atoms, electrons, photons, and other particles are an integral part of our science, no one has actually seen any of them. Even the atoms are too tiny to be seen even with the best and most powerful microscopes. Therefore, we have to resort to tricks in order to be able to study particles of the subatomic range. This is usually done by observing their effects in the visible world. Thanks to the ultra-short light pulses of attosecond physics, scientists can depict the rapid movements of electrons in atoms and molecules, and this observation of the dynamics of electrons allows us to better understand the fundamental processes of matter, and therefore our entire reality. We can see even better how chemical bonds are formed and broken again, or how photons interact with matter. These discoveries not only satisfy the curiosity of scientists, they can also help us develop new materials or improve solar panels. Imagine that we invent plastics that can turn themselves back into their natural components, or solar panels that repair themselves and, accordingly, last longer. All this will be possible if we understand the world of the smallest particles and the processes that set them in motion. Thus, attosecond physics opens another window into the hidden mechanisms of nature, and allows us to better understand how our world works. Quantum computers. Thanks to the attoseconds of Louis Liu, Pierre Agostini, and Franz Krauss, Nobel laureates in physics in 2023, each made significant contributions to the physics of attoseconds in their own way. And Louis Liu focused on generating overtones by passing infrared laser light through an inert gas. It's a bit like how sounds in music are dispersed into different keys. The inert gas separated the light pulses, creating overtones close to attoseconds. Pierre Augustin managed to generate light pulses that lasted only 250 attoseconds. And Franz Krauss is another pioneer in working with extremely short light pulses. Today, scientists around the world are conducting research with attoseconds, and quantum physics, which also deals with the basis of our reality, also benefits from this science. The technology may even bring decisive advantages in the development of quantum computers. For example, thanks to attoseconds, we will be able to deal with the problems of cooling and sensitivity of quantum computers. until now. These supercomputers have only functioned when they were extremely stationary. Even the slightest vibration can distort the result of calculations. If we understand the realm of electrons, we may be able to stabilize such systems, as well as neutralize temperature problems. Quantum physics and the nature of reality sounds crazy, but our entire reality is formed by tiny particles that don't really exist. Quanta have some fascinating and at the same time confusing properties. They are in several places and times at the same time. They form matter only when they are observed and disappear when we do not observe them in an unknown sphere. It may sound like our reality doesn't really exist, but that's only partially true. This seems to be the case with the laws of the lowest subatomic physics. This macroscopic world is very unstable when we try to describe it or approach it using our physical means. Nevertheless, this instability shapes everything we see. One of the fundamental aspects of quantum physics is called particle-wave dualism. Electrons and photons are also quantum particles, and they can exhibit properties of both waves and particles. For the first time, this became noticeable thanks to the famous double-slit experiment, in which a particle beam sent through two parallel slits turned into a wave-like interference pattern. It was only when the quanta were measured that the line appeared. This behavior contradicted our idea of particles as well-defined objects that always have a certain position, shape, and velocity. These fixed properties are just one version of reality. The other is a wave one, in which reality becomes a quantum of uncertain possibilities, and both seem to exist simultaneously. An interesting threshold in this subatomic world is the Heisenberg uncertainty principle. Up to the S limit, we can practically detect and measure particles, after which they behave more and more unpredictably. The closer we try to get to their essence with the help of previous methods, if scientists are after them, then they practically evaporate. It's crazy, isn't it? And you have to imagine that this is happening everywhere and at any moment. You are made up of quanta, the table in front of you, or even your computer. In essence, this means that your computer falls below the Heisenberg uncertainty limit, into spongy nothingness. And perhaps this threshold is even the entrance to a completely new physical dimension, or to a previously unknown world. We do not know how the universe continues in the subatomic realm. We also don't know how our universe continues to exist in size and immensity. Quantum entanglement is another phenomenon that challenges our understanding of reality. When two particles become entangled, the state of one of them immediately affects the state of the other, regardless of the distance between them. Einstein called this phenomenon a creepy action at a distance, and in the end, it means nothing more than that the quanta communicate with each other throughout the universe, carry and transmit
similar information. Our matter is formed in the macrocosm from the building blocks that supernovae, that is, exploded stars, have sent into space. The quanta in your body are probably confused with the quanta that came from this very supernova, and they exchange information. Let's take another look at the superposition. This concept states that a quantum system can exist in several states at the same time until a measurement is made. The most famous example of this is the Schrödinger cat thought experiment, where a cat in a box is considered alive and dead at the same time until the box is opened. However, in the end it may also mean that many realities and dimensions exist side by side. For all these reasons, physics simply cannot answer the question of what reality really is. It almost seems that the possibilities are much more real than a certain reality. If we view reality as something we experience every day, or what happens to us, is the passage of events and time. These events are certainly real to a certain extent because we experience them every day. But perhaps this reality is not the only thing that exists. It would also mean that the results of the truth and knowledge of our scientists are nothing more than variations of countless realities. We create reality. It may seem strange, but it's true. Science will probably never be able to fully describe the true nature of the universe and our reality, at least with the current means. This can be frustrating if we really want to get all the answers at once and completely. Science is a vast field in which physicists, chemists, mathematicians, and many other scientists are trying to get to the bottom of the nature of our world. In the process, we are constantly discovering and developing something new and making tremendous progress as a species. Imagine that electromagnetism has always existed in nature. The ancient Greeks observed it and described it in various works. But unlike us, They couldn't capture these effects, simulate them, and use them for themselves. Otherwise, Socrates would have been able to study and philosophize by the light of a light bulb. At first, we had to do more and more research. And we have such things as plastic, coating, glass, and many chemical components to make the forces of nature our own. Nevertheless, the basis for this was the discoveries of antiquity. Observing, studying, transforming, and using nature, we can see very clearly how we humans create, shape, and change reality. Large-scale changes on our planet, which consist in brightly lit cities, airports, skyscrapers, and much more, are a reality created by us from the forces and raw materials of nature. All this has become possible only thanks to science. And every year in Stockholm, scientists, academics, and prominent personalities come together to celebrate the best representatives of scientific disciplines by awarding them the Nobel Prize. The Nobel Prize was established in 1901 by Alfred Nobel, the inventor of dynamite. Nobel decreed that his fortune should be used to establish a prize for all those people who have brought the greatest benefit to humanity. Today, Nobel Prizes are awarded in the categories of physics, chemistry, physiology, or medicine, literature, and peace. Among the most famous laureates is Albert Einstein for explaining the photoelectric effect and Marie Curie for the study of radioactivity. Stephen Hawking received the award for his work on black holes. And now the prize has been awarded to 3 people who make the world of Atoscons accessible and understandable to us. Subscribe to the channel right now and wait for many more exciting videos.
Мы можем очень ясно увидеть, как мы, люди, создаем, формируем и изменяем реальность. Масштабные изменения на нашей планете, которые заключаются в ярко освещенных городах, аэропортах, небоскребах и многом другом, это реальность, созданная нами из сил и сырья природы. Все это стало возможным только благодаря науке. И каждый год в Стокгольме ученые, академики и выдающиеся личности собираются вместе, чтобы отметить лучших представителей научных дисциплин, вручив им Нобелевскую премию. Нобелевская премия была учреждена в 1901 году Альфредом Нобелем, изобретателем динамита. Нобель постановил, что его состояние должно быть использовано для учреждения премии для всех тех людей, которые принесли наибольшую пользу человечеству. Сегодня Нобелевские премии присуждаются в категориях физики, химии, физиологии или медицины, литературы и мира. Среди самых известных лауреатов Альберт Эйнштейн за объяснение фотоэлектрического эффекта и Мария Кюри за исследование радиоактивности. Стивен Хокинг получил премию за свои работы о черных дырах. И вот теперь премия присуждена 3 людям, которые делают мир атосекунд доступным и понятным для нас. Подписывайся на канал прямо сейчас и жди еще много захватывающих видео.